Right. Good afternoon. Today we're going to do a new chapter. We start a little bit on this hypothesis testing. Basically, what we're going to do in this chapter is we're going to analyze some situation. Okay, we're going to analyze some situation, and we're going to draw up a conclusion quantitatively. Okay. Some situation and somebody will claim that some statement, and we're going to see whether can we come to a conclusion whether right or wrong about that statement. Okay, we are going to do this by quantitatively, and I'm going to teach you step by step all these things step by step. Title is hypothesis testing. All right, all this you can read yourself. Basically, in any kind of situation there are two assumptions. Basically, in any kind of situation we will consider two assumptions. One is known as null hypothesis. Hypothesis means and assumption. One is known as null hypothesis. This is always equal to, okay, equal to some number. Another one is alternative hypothesis. We will see one example. Okay, look at this example. Hypothesis testing for single population mean. N is greater or equal to 30. The one I gave you is you have to fill up certain value inside the slides. A manager of a health store believes that the average amount spent on a week on vitamin C supplement is this one. Okay, the manager believes that each and everybody in the world spending 2 ringgit 50 cent for vitamin C. Okay, no need to go by world because it's RM, just leave it in Malaysia. This one manager believe that in Malaysia each and everybody is spending 2 ringgit 50 cent for vitamin C. So the Malaysia thing is population. So on average, this is your population mean. A random now to test whether each and everybody is spending 2 ringgit 50 cent. Only 100 shoppers are selected. 100 shoppers are selected, and we find that the average expenditure these 100 shoppers spending for vitamin C is only 2 ringgit 40 cent. Okay, and standard deviation is 0.4. Test the manager's belief at 5% level of significance. So how to do this? Okay, let me rephrase back. There is one manager believe that in Malaysia population everybody is spending 2 ringgit 50 cent, and then 100 shoppers is selected. This is sample. Only 100 shoppers selected, and we found that out of these 100 shoppers, we found that they are only spending 2 ringgit 40 cent on vitamin C. Okay, can we conclude that with these 100 shoppers and these 2 ringgit 40 cent, can we conclude that every people in Malaysia spending 2 ringgit 50 cent? Can we do that? So that's what we're going to calculate. If you guys cannot hear me and cannot see the screen, please let me know, because now today the network, the coverage is a little bit weak here in UTH. Alright, I suppose all of you have the slide. You need to fill up certain things now. Now, first of all, state hypothesis. Step 1, state hypothesis. Okay, null hypothesis is denoted by this. Always remember, null hypothesis is always equal, put mean equal to some number, population mean. Population mean is given there 2 ringgit 50 cents. Null hypothesis, you can write it as not equal, greater or less than. Okay, depends on the question. In the question, they say test the manager's belief. They never say the manager belief is greater than or less than. Then we put less than or greater than. We will see some other example later. Okay. Now this one, you just put test manager's belief. If they put test manager's belief, you cannot see any hint on greater or less than, you put not equal to. Okay, this is the first step you have to write. I just want to double confirm. Can see my screen? Can you guys see my screen?
Yes, sir.
Okay.
Yes, sir.
Okay. Now step 2. Step 2, state the significant level. Okay. Later I will tell you what is this. What is this? This means. Step 2, state the significant level. That is 5%, 0.05. Copy. Step 3, state critical value. Okay, so how I get this critical value? Since this is not equal is a two-tailed test. We call it two-tailed test. What you have to do for not equal, you divide 0.05 divide by 2. 0.05 divide by 2, you are getting 0.025. So it's a two tail. Both tail you write here 0.025. And I call this as rejection area. This red color is rejection area. The blue color is acceptance area. The blue color is acceptance area. Okay, you will get my point later on, don't worry. Now for 0.05, what is the critical value if you compute from your if you compute from, if you see from the reverse process 0.05, so 0.05 is 1.96. okay, so here is, this one is negative 1.9, this one is positive 1.9. That's how I get plus minus 1.96. I give you some time to copy this. All right. What is this rejection area and acceptance area? Then we will see one. Calculate test statistics. Okay, by using this formula here. This formula here. This formula is only for n greater than 30. You can see here n greater than 30. For n greater than 30, we are going to use this formula, and you will calculate the test statistics. This is the determinant for us whether we have to accept the manager's claim or not. So how to calculate? The mean, the sample mean minus the population mean, standard deviation is given there, sample size is given there. If you calculate, you get negative 2.5. Now after calculate the test statistics, now you see just now this value, just now we have identified the acceptance region and rejection region, isn't it? This one is here negative 1.96, 1.96. So this one is, this part is acceptance region, isn't it? So look at this number. This number is negative 2.5. Where is negative 2.5? Somewhere here, isn't it? Negative 2.5 somewhere here. It falls in the rejection region. Okay, it falls in the rejection region. Okay, so the next step is comparing the value. Compare the test statistics with the critical value. We notice that negative 2.5 is on the left hand side of negative 1.96. so I put like this, smaller. Copy this one first, this diagram. Since this value in the rejection area, okay, now you write this, because just now we saw negative 2.5 less than, and then because it falls in the rejection region, we reject null hypothesis, only null hypothesis. We write like this, we reject null hypothesis, and since we reject null hypothesis, what is null hypothesis? The population mean is 2.5, isn't it? 2 ringgit 50 cent. We reject this. Since we reject this, we have to write the conclusion like this. Evidence does not support the health store managers' belief that the average spending vitamin C supplement is, okay, this is the full answer. All right. So we did a quantitative method to come to a conclusion that to believe the manager's statement or not, okay, the manager's claim. So according to our computation, it tells that we cannot believe the manager's claim. What is the manager belief or claim? He said the vitamin C supplement is 2 ringgit 50 cent. But when we take 100, when we go for the 100 sample, okay, we approach 100 people and we take the average. When we get 2 ringgit 40 cent and we do some research analysis called hypothesis testing, we come to a conclusion that it is not true. The manager is not true. Okay, but of course this is very subjective. Okay, this is very subjective. As I told you, this is quantitative method to come to a conclusion in real life situation. We may be wrong. We may be wrong. Our computation, or we may be wrong. What is the probability? What is the probability we are? What is the probability we are wrong? Our computation will be wrong, or our conclusion is wrong. We may be wrong because it's calculation. Calculation. How you going to settle? How you going to solve real life situation? Belief or not, subjective matter by calculation. So it won't be 100% right. We may be wrong. So what is the probability that we are wrong? This is the probability. This is where the significant level comes. This is the probability that we are wrong. So what is 0.05, which means how many percentage we may be right, or we will be correct? How many percentage? 0.95. The probability that we may correct is 0.95, and this is we are wrong is 0.05. Okay, that is where the significant level comes. Okay, now look at this one. Try to read this. The expected mean diameter of a batch of a cable is 2 cm. Okay, expected mean diameter of a batch of a cable is 2 cm. So diameter of a cable, this is, there's a cable here. So this diameter is 2 cm. This is the population mean. This is population mean. All the cables, when we consider all the cables, it is population. The quality control inspector takes a sample of, what is the sample? 64. He take only 64 cable. This one is all. Now he takes 64 and just want to test what is the diameter, and he find out that out of the 64 cables, the diameter is 1.94 and standard deviation 0.4. Can we test whether the manufacturing process is now producing cable with smaller diameter than the previous in 1% significant level? So now we want to test whether it is smaller. Okay. can we conclude that initially what is our claim? Initially what our hypothesis is, each cable the diameter is 2 cm, and then the inspector takes 64 cable and finds that the diameter is 1.94 km. Can we conclude that each cable is now smaller than 2 cm? Because 64 cable gives us 1.94, can we conclude that each and every cable now is less than 2 cm? Can we conclude that? So let us see. Again, what is the hypothesis? As I told you, null hypothesis is always equal. Okay, equal to cm. And alternative hypothesis, as we already see from the text, they say we want to test smaller than diameter, so we put smaller here, less than. Now state the significant level. So now you know what is significant level. Significant level means the probability we may be wrong. Okay. Now since just now I told you not equal means two tail. Two tail. Now whenever there is no equal, either like this or like this, you follow the arrow. Now this one this one I call it as one tail test. One tail test. Follow the arrow, the tail is this side, left hand side. So now the whole, because the tail is left hand side, the tail is here now, left hand side, the whole percentage, the probability is 0.01. You don't need to divide by 2. Only two tail you have to divide by 2. One tail you don't need. This is one left hand side, one tail test left. Okay, left. My F and T looks exactly the same. Left. So if 0.01 is here, what is the critical value? Go back to the Z table. 0.01. This is 0.01. 0.01. This is 17. This is 10. 2.33. Yeah, I go for this one. 2.33. So 2.33, since in the left hand side it is negative, that's how I get critical value. Okay, after the critical value, what we do, we go for calculated test statistics. We know the sample is 1.94 minus this, you get negative 1.2. So just now this is negative 2.33. This is rejection area. Okay, this is reject. Where is the acceptance area? The acceptance area is 1. Now all you have to do is, where is negative 1.22? Somewhere here, isn't it? This is negative 1.2. So it is in the acceptance area. Okay, in the acceptance area. So before we write we accept the null hypothesis, just write negative 1.2 is greater than negative 2.33. Like this, huh? Now once you compare, we know it is in the acceptance area, so we accept null hypothesis and we write the conclusion. Evidence does not support the manufacturing process is now producing cable smaller diameter. Okay, so we cannot tell it is smaller diameter because we accept null hypothesis. Null hypothesis is what? Is 2 cm, isn't it? Still the mean is 2 cm. We accept the mean is 2 cm, so we cannot conclude it is smaller than 2 cm. That's why I write does not. But if you want to write evidence, if you want to follow the null hypothesis, evidence support that the manufacturing process is now producing cable with the diameter of 2 cm also can, no problem. Evidence support that the manufacturing process is now producing cables with diameter 2 cm. This is also I can accept, but I prefer to write like this to answer the question. Now try this. Okay, you try for 5 significant first. You read this, you try. I can give you a hint. Is the manufacturer claim justified? The null hypothesis should be not equal. You try for 5 first. The one you leave it first. Right, check the answer here for now. For 5, now you can check answer for 5 percentage, and at the same time you write the answer for 1 percentage. I'm doing simultaneously. So state hypothesis, this is your hypothesis. Okay, significant level 5 percentage and 1 percentage. So this is two tail, because not equal to two tail, you have to split. So this one you have to split into, for this one you split into 0.0, this is 0.025. I think this is the critical value will be negative 1.96, this one is 1.96, and for this one you also split into 2. And what is the critical value here? 2.58. So I am getting here 2 point. You can check in the table. So once you do this, you will get critical value like this. Of course I have written here, okay, already right here the critical values. So you write the critical values like this, and then you have to find the test statistics. Here test statistic is negative 2.86. So just now for this one, here and this negative 2.86 is somewhere here, so rejection region, in the rejection region. Same goes for this one. The critical value is negative 2. It is also rejected here. So in both case we reject. Both case we write this is less than the statistics value, and both case we reject and we write the conclusion like this. All right. Okay, one last one. Maybe you can try one last one. Try this one. Check the answer. All right. And you accept. Oh, there's another one actually, but anyway, never mind. Copy these answers and double check. Okay, so this would be the answer for this exercise. And for exercise in class 5, you can try yourself. Okay, this exercise you try yourself, and I think, yeah, after that next class we go through n. If n is less than 30, then what do we have to do? Okay, so this exercise class in 5, you try first. Next class on Sunday I will give you the answer. You can check the answer. Alright, with that, that's all for today. I'll see you all on Sunday then. Take care. Bye.